Hello. How's it going? Welcome back to yet another live stream on the weekend. And today, what are we doing? Today, we are just gonna do some Leetcode, go over some algorithm problems, and try to solve some problems. And let's see. Hello. How's it going? I think. Welcome back to yet another. My bad. Okay. Yeah. So today we are going to be solving Leetcode, as I mentioned. Um, Why Leetcode? Because I opened Leetcode. I was solving some Leetcode in the morning, and I thought, okay, the evening when I'm doing it again, I didn't want to work on the full stack app today, and I was like, yeah. So maybe just today, I'm just gonna do some algorithmic problems. That's all. That is what the plan is, and yeah, it's been a hectic Saturday. A lot of stuff going on, but yeah, we're finally live in the evening, and we'll try to see how much we can do. It's already 8 o'clock at my time. And good evening, good morning, whoever is watching from all over the world, anywhere you are, whatever time you are. I hope you have a good day and I hope you have a good evening. So, yeah, saying that, one quick thing is, yeah, how's everybody's Friday? How's everybody's Saturday going through? And yeah, do let me know in the comments. And if you have any questions while we get started, right before that, I'm going to quickly do a promotional post. You might ask, why haven't I done it now yet? Well, I was just posting on other platforms, LinkedIn and stuff like that. I post from my PC, but for WhatsApp, I do it from my phone, because if I don't put the WhatsApp status from my phone, the what is that called? The preview thing doesn't come from WhatsApp PC, and it's pretty dumb why it happens in that way. But yeah, it is how it is, I suppose. So yeah, let me quickly share it. Share here. Let's go copy. And here I can quickly say going live. Solve some paper today. Cool. Yeah. Now that we have that out of the way, how's everybody doing? Feel free to leave a comment on the chat. Yeah. Other than that, we are quickly gonna go ahead and get started, I suppose. So I still have my phone on today and not on D&D, because I'm expecting a call which I think I need to attend from my home. But yeah. Okay. Cool. I think we can get started. Maybe even I should like my own stream. Why not? Why? Me first. Cool. My hair is completely messed up for the past, I don't know how many days. Just been trying to get it correct. I had a new haircut and I went to actually a new place, and I feel that yeah, it's probably not worth it. This place. But okay, whatever. We're gonna get started now. I cannot hear a little bit of music. I want a little bit of kick. Are you guys able to hear some music? I hope so. Yeah, this is this. I hope so you guys can hear a little bit of music, right? And not too loud. Cool. So, what are we doing today? We are solving Leetcode, as the title says. But as we move through, maybe I switch over to AlgoExpert or Leetcode or something. I'm not sure. But yeah, so this is Leetcode, and I actually tried to do the a problem of the day, problem today in the morning, and it failed with TLE. So yeah, it failed with TLE here. Where's the submissions? Okay, so that's wrong answer for sure. Yeah. So if I just use this code in here, how can I use it? Okay. So yeah, it basically fails in the last one or two problems. So that's one thing which I don't like. So what the problem is a very simple thing. So you have a router which you have to design a router class. Yeah, it goes. I think on the very last. Oh no, there are actually a couple of them left. Not the last one or two. It's almost the last 10. But anyways, what the problem statement is that you have a class router, and what you expect it to do is has a fixed length of memory, a fixed memory capacity, and you have certain packets coming in, and each packet has three things, which is a destination, sorry, a source, a destination, and a timestamp. So source tells where it's coming from, destination tells where it's going to, timestamp says where it's coming to. So that's there. And what is expected is that you keep on appending things, like you store them somehow. So there are three functions. One is add packet. So if the same source, destination, and timestamp does exist, sorry, uh, uh, yeah, timestamp is considered to be duplicate if another packet of the same source, destination, and timestamp already exists in the router. So that would be a duplicate timestamp, a duplicate packet. So you have to return back false on that case, and return true and add the packet if it's actually the same. But the more important thing is that there's a memory limit. So if you hit the memory limit, whatever was the first guy who came in, the oldest guy who actually entered into your stream, let's say, it basically needs to get popped out. So what I do here is that I keep a set to track if they are duplicates or not, and packet is nothing but a record or a data value which is having source, destination, timestamp. Then you can have then I basically say that okay, I use a deck. I use a deck because what I want to do here is that sorry, what I want to do here is that okay, if you are hitting the memory limit, this is when you pull out one of them, and yeah, you basically add to the set and to the sync. Forward packet is basically, again, it's kind of just pop out the first one. If it is empty, you have to return a empty array. That's all. But here it's what gets interesting. Get count. So get count would be given a start time and an end time, and inclusive of those two timestamps. So you have to get the number of packets that you have received, where the destination is this thing that they have given. All right. So this is where I simply just do a often solution iteration over the entire deck and say that hey, can you give it to me. The problem here is that I have to first change it to an array because of how I am iterating over it. Okay, that's one thing. So definitely one of the things here is that you unpack it, and so packing is so not here because it's packet, it's a data type and not int and these things. But this is pretty slow. So one thing I want to do is I just want to check if I can just iterate over the original queue and not over these things. So I tried a little bit of binary search also where it didn't work out quite well, and that also had a time limit exception, and it had um, I had something. I forgot what I had, but I had something. Wrong answer. But yeah, so yeah, this is the type of binary search that I was trying to do. But what I'm going to do here is that I'm going to say this, and in here this needs to be public for this particular case. It's basically saying that these things can be final, which makes sense because these are references, so they never change. That's fine. So here, one thing I want to do is, can I just do deck dot port? Look at that. So so in here there is a simple problem here. Can anyone tell me what is the problem here? This here is a local variable, so it has to be final. So I cannot change it. Well, I can do one thing in here. Count is this. So I just change it to a reference, And well, I don't change the reference, it should be fine. I can change the contents. I want to quickly see if this is gonna actually improve something. I quickly want to figure out I've done this correct. Okay, so if I do a submit and see exactly what's going on. Yeah, it still times out. So this, I feel this iteration is the issue, I feel. So can I just go ahead and use the test case? Okay. So it even time limit exceeds even without any other test case running. So this is a genuine concern. And what is the constraints here? The constraints here is 10 to the power 9 timestamps and 10 to the power 5 calls will be made to this thing. Okay. So I feel we still have to go with some sort of n log n solution to actually say that, okay, we are good and we are not, you know, having an O of n square solution. So what can we do here? One quick thing that I want to see here is how do you do that? I forgot. So if I have packets, I can say enumerate, right? Not enumerate. What is it? Iterator, not enumerate. So here, can I say iterator? Sorry. Yeah, so we can do that. But as a matter of fact, we know this is not going to work, right? As a matter of fact, we know this is not going to work. The question is, can I just do text size and get first, get last? Okay. So the question is, how do they hide get? So we cannot do that. But yeah, so we still cannot do a binary search here. Ugh. Mm. Yeah, seems like this is also gonna get TLE. Okay, so this is not the problem. The only thing I have to think of here is what I feel is how to do a get count. And I feel this has to be a binary search. But to do the binary search, I need access to yeah, I basically need access to that queue. And I should be able to iterate over that queue. Also, this doesn't seem to be the problem. Because even though I do this, wait, is that the problem, by the way? Feels like that is the problem. Get count. So how do we get a count quickly for a specific destination within a range? The first hint I'm going to look at is not hint. I'm going to look at the topics and see exactly what is there. Array, binary search. Dude, I already mentioned binary search. Okay, let's see if this works, right? Because a binary search was wrong answer, but not time limit exceeded exception, right? So in here, the first thing I'm gonna do is packets dot to array new package array. Okay. Left index is sorry, it's gonna be z. It's gonna be -1. So what? Why -1? The reason behind that is you have given me a start time and given me a end time. So we have to look between these, and I'm trying to find an index where I need to start. So the start time has to be sorry. There's one important thing here. Add packet will be made in increasing order of timestamp. Okay, increasing order of timestamp. So that is why, as you can see here, 1490, 2590, 1490 again came back. So once you go over 90, it always will, like, if it's 91 series now, it can never be 90, which means that by default everything is already sorted for us, right? So we don't have to bother much about that, I feel. We don't have to bother much about that. What we do need to bother here is, where is this thing? What we do need to bother here is that if I find the start time somewhere in here, that's one of the viable positions to start, and I need to go more left because there can be a better answer to the left. So as an example, if the destination was 4, this is 90, but there is also a destination for 5 which is for 90, so I need to go left for sure, because I'm going to go from left to right. So from left to right, obviously within the range your other things will already be considered, so I have to go to the leftmost start time, or leftmost greatest number than start time. All right, so if start time is 90 and I don't have a 90, I have a 91, I want to start from 91. Okay, that's what it is. Yeah, so, and here, let's say if it started from 70 and I'm starting for 90, I'm looking for it, this would be -1. So it would never actually, like, I will never say that anything is within the range. Sorry. So what you have to do is, if I'm hitting greater than equal to, I have to remove everything on the right side, reject them, which means I have to move the right point. But if I am encountering something less than the timestamp given, my answer might be lying on the right hand side, so I have to move the left one. So that is what it is. So index left, left is 0, right is sorry, array dot length -1. While this, look at that, does everything for you. Okay, so mid is left plus right -2, divided by 2. Sorry, I'm a little distracted today because I'm expecting a text from someone, but yeah. Okay, so after that, what I'm going to do is array mid dot timestamp. If timestamp is greater than or equal to this, well, start time is greater than or equal to this. Left index would be mid, and then right would be this, and else left equals mid plus 1. Sorry. If this is this, I'm simply gonna return 0. Now I can copy paste the code a little bit. So now this is right index. So if right index is -1, what does it mean? It means that everything is above your range. So I mean, this should never be -1 because yeah. So what I have to do here is that less than equal to. So if I am on the right hand side and I'm less than equal to, I want to go more right. So I'm going to say left equal mid plus 1 because there can be something better on the right hand side, right? So we can copy paste this snippet one more time. If end time, oh my god, if it's less than equal to end time, so right index is this, and this would go here, meaning this would go here. Yeah. Okay. So now, within that array, sorry, what's it called? Array. Array dot stream dot can I do a range or something? Java 8 stream array range. Array view. Uh-huh. But I have doubt that this is also gonna fail and not be that performant. Yeah. Let's see. Let's see. Yeah, it's already time out. My bad. This is what I wanted to. This is what I wanted to replace. Yeah. Okay. Time node still exceeded. Good. Let's look at a little bit of hint here. I think a DQ. We already did that. Use binary search with the type. Dude, I'm exactly doing that, but I still have to do a binary search for that particular thing, right? For that particular destination. It's not just for any destination. It has to be for this destination. So once I do find out the index, I do still have to iterate over it to figure out, right? Okay. Y left is greater than equal to right. Sorry. So let's see how lead does. How is my solution? I get it clearly. Can you suggest me what to do better? You know what? We can also keep a map of destination to the timestamp. You know what? So we can keep a map of we can keep a map from integer to the deck of integer destination map. It's really not a great idea, but okay, let's see. I mean, memory is going up high, so that's for sure. But let's see. So here we have to do one of the things. So since we already pulled it out, what we have to do is we have to say memory, destination map dot get b dot destination dot hold first, because that would have been the thing, right? So what you're saying, it can be null. It has to be null, honestly. Okay, so it has to be non-null. My bad. After that, what I want to do here is that I want to add this. I'm going to add this. Then I want to say destination map dot this thing, yeah, dot get destination dot offer last timestamp. So here we don't do that. We say destination map dot get destination yeah. I think I have to do integer. In fact, integer I think is better because it won't be doing any boxing, unboxing, things like that. So here is this, and here is this, and count can simply be returned right index minus this thing, plus 1. I feel that should be it. Leet was of no. Wait. Leet was of no use actually. Like I didn't actually ask. Let's see if this actually solves the main problem of a time limit exceeded exception. Well, this is gonna fail because. Hmm. Okay, this is straight up saying you're wrong. Wrong answer. Also, the runtime is very, very bad. Yeah. They don't have an editorial for this, so let's look at some solutions. I've spent the morning also in this. So 100% medium problem with easy approach with 5 languages. Can you just give me one problem? I realized we need a data structure, blah blah blah. Get duplicate efficiently, count packet by destination really quickly. Instead of strings, encode the packet as a single integer key. That is kind of a really interesting approach because it's gonna be fast. Maintain a map of destination. Dude, am I not doing the same thing? Am I not doing the same thing? Hmm. Okay, so then you say forward the packet. Only the count is wrong, honestly. Other things are correct. Yeah. The get count is wrong in here. Yeah. Also, should be here. Hmm. Let's ask. Is it a generic question or it has context of what I am? Man, it's doing some thinking. Okay. The fuck is this? Where do you get this functions? Feel okay. Wait, actually given a problem? Still generating something. Okay, while it generates, I'm just gonna be back. I do remove from it, man. Sorry. Shoot. Shoot. Well, one thing I have to do here. Okay, so last one is still an issue. Holy shit. One thing we can do is we can try and use my diff tool. It's gonna take some time because it's not optimized. Ah, snap. I'll just be back in a second. Yeah. Okay, I am back. And so one of the things I think is that you know the main problem here is I feel the main problem here is that is my face okay? Something okay. Anyways, so I think the main problem here is one of one of the things from a memory perspective and time perspective I'm aware of is that if we can actually get things working with uh, if we can actually get things working with primitives instead of integers, it would be awesome. So the question here is, can we do that? Not quite sure if we can do that. So you know what? Maybe this is another problem. If we can, so as we was looking at one of the examples where they're encoding or hashing it in a way where um, it makes much more sense to not have all of these things together. So technically speaking, still need this. Maybe we can do this. And here, and this has to be this. This has to be this. And this has to be an integer. Okay. So when we add the packet, one of the things we can do here is, so let's keep that for now. Private int hash. So int source, int destination, int timestamp, return objects dot hash, these three things together. And we can remove that, and we can say int packet is basically hash this thing, and if packets contain this is false. Cool. So if this is this, we would take out the packet first. It would be this actually. After that, we need to remove this thing, right? So man, I hate that, but okay. So what we have to do is int p equals hash of array of 2. Okay, so this is saying that okay, it can produce null pointer exception. I wish we had something like this in Java, but we don't. But just to say that this is not going to be null, object star require non-null. We can say that, and if it's null, it throws an exception. If it's not, then it returns back the object. Then you take this, you remove this. So in here, array of 2. Well, technically speaking, array of 2 can also be, no, it cannot be null because it's always an integer, this thing. Okay. So now here, offer last new int source destination timestamp. Okay, I'm gonna add the packet here. So I'm gonna take the destination and maybe not memory limit, I just put that. and here this is this. Okay, cool. So if it's empty, you return back an empty this thing. So poll first would give you back an array, and then in here we can copy paste some of the things. We can call this packet, packet, packet. So you remove the packet, but here also you need to do some things. So destination map dot get this thing dot poll first, and then you're gonna return the array. Okay. Then you have count, which seems to be the correct thing. So will this actually go through is my question. I have doubts, but let's see, because this is the kind of solution that I think in the solution also somebody was doing that, but let's see. Motherfucker, it came a null pointer exception. The fuck? So it never added correctly. It never added correctly. Okay. So this is empty. This is null. But I always say new array tech. System dot out dot print ln arrays dot toString. I'm gonna say array in here, and then so let's do it in this way. If array is this and map is this. Okay. Destination map. Let's just see what happens, and I'm gonna remove the other test cases for now. Just gonna run this. Okay, cool. But you never actually told me where. Why this didn't print? Oh wait, it did print. Okay, my bad. Sorry. But we are not logging whatever we are deleting. So D D G. Source destination timestamp. Okay. So if we do this thing now, you're gonna simply gonna say, okay, we are trying to remove 4505, which is this guy here. Yeah, there's only one entry here. Sorry. And the map has 4, which is 90. The map has 5, which has 90 and 95. But we also did a remove, right? Forward packet. No. Okay. So you did this, and then you're trying to do this. So it has hit the limit now. Oh, I am an idiot. That's why. Destination is array of 1, not array of 2. My bad. Yeah. Okay. Okay, this works fine, and this runtime came down if I'm not wrong. Previously it was running for quite a bit of time, so let's do that. It's the wrong answer. Shiz. Ah. Is that what you're looking for? No, right? It doesn't even quite tell me what exactly went wrong. That's the problem. It doesn't quite tell me what exactly is wrong. Well, one thing we can do here is take this. This is a single line. So you can just go here and we can say take every comma and replace it with comma and a new line. Cool. Okay. Take this. Take the comma, or do that. Okay. And if I just say find if, where's the hunk, buddy? Okay. False true. That's the issue. Other than that, everything seems to be correct. So my answer says false, which means it added to the list. But technically speaking, it shouldn't have been added to the list. Because you're already supposed to have 37, 20, 107. Okay. Maybe the hash is wrong. Maybe we have to do something else. What exactly can we do? Source and destination maximum can be 2 to the power 10, 2 into 10 to the power 5. Timestamp can be 10 to the power 9. Okay. So here, if I look at this, okay. So if I take the binary of this guy, this is a binary of this guy, right? I hope it's visible. Yeah, this is a binary of source and this thing. So how many characters are there? There are 18 characters. So 1 2 3 4 5 6 7 8 9 10. 1 2 3 4. So this here is the actual 32 bits of this. So if I just say int of this base 2, gives me back exactly the same thing, right? Yeah, this gives me back exactly the same thing. Okay, so what is a, so 18 is the like highest set bit, right? Then here this is 10 to the power 9. So if I just take the binary of this guy, so how many are there? 30, 1 2. So this is this, and 30 is the maximum bit set bit of this. Okay. So we need 18 bits for source, 18 bits for this, 18 plus 18 plus 34, 30, which is shit, man, 66. I was hoping it's 64 so that I can pack it in a long, but it's not. So now I'm not very sure how to pack this. So because what I was thinking is, if I take a 64-bit number, right, So this part can be taken care, represent this thing. And if it was like within 64, I would have taken half of the bits here for source, the other half for destination. But sadly, that is not what it is, right? So the question is, how do I encode the information? Okay. Uh, we have three variables. Okay. So we have these three variables. Now, binary of source or destination maximum. Max value of source destination is this. So 18th position is the maximum set bit. For timestamp, it's this. So 30th, we were technically speaking considering 1x. Now, this means I cannot encode these three into a 64-bit integer like first 32 timestamp, then 16 for source or destination, and then 16 for source, because we can have total 66 bits, not 64. What's another, what's a way to encode this info? Let's see what it actually has to say. Come on. Can you just, okay, nice clear problem. You're right, with maximum listing, the straightforward bit factor is impossible without changing something below a practical timestamp. Needs, okay. Shift the timestamp baseline. If your timestamps are clustered, this is not a real problem with actual data. This is Leetcode. This is the code to implement a router. So adds a new packet to the router if packet already exists. Source destination timestamp same, do not add, return false, else add, return true. If memory limit is hit, remove the first in, basically oldest guy, oldest entry gets out. Forward packet removes the oldest get count returns the count of packets for a destination within start time and time, both inclusive. Okay, so let's see what it has to say now. See what it has to say now. You used array2 when you were meant for wait. I probably didn't change it here. More correct use of packet. Using packet is giving clearly. So we need efficient solution. Lower alert solution with no of an average move and log of n range queries per this thing. Okay. So you have a deck, you have a hash set of keys. Well, what the fuck is a key? Key is again a lightweight cache. Okay, cheap combined cache hashing. Okay. Man, it's still gonna be boom, 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 boom. Okay. I'm gonna take a break from this and try and solve some other problems because this is a jack and a pain in the ass problem, honestly. So I don't want to do that. Let's actually save all my problems today. See if there's something we haven't solved. Okay. So let's look at the last 6 months. Okay, now we have some problems which we haven't solved. So it's not solved. Okay, let's see. Hopefully we don't have to scratch our heads for this. Okay. Next greater element 3. Okay, this sounds interesting. Given a positive integer end, find the smallest integer which exactly has the same digits existing in integer n and is greater in value than n. If no such positive integer exists, return -1. The returning integer should fit into the 32-bit integer. If there's a valid answer, but it doesn't fit in a 32-bit integer, return -1. Oh man, I hate this range check problems, honestly. I hate it, honestly. Yeah. Well, one of the things we can do is always cast into long and work with long. Long has 64 bits to work around, and which is this huge giant ass number. 2 words. 8 quintillion 400 something. Holy shit. And wait, I should do 63. Yeah. Sorry. So what is it? 9 quintillions, 200 quadrillion, trillion. Yeah, that's a huge ass number, right? So if I just do this, this is this. 2 billion. Well, it has to be -1, but yeah. Okay. So what is the solution that we can do, huh? What is the solution that we can do? The question here is the next greatest number, correct? Find the smallest integer which has the exactly same digits existing in integer n and is greater in value than n. What I feel is we can go from the right, and the moment we see that there is a possibility of swapping something, I am going to swap. Okay, so as an example, you have 20, we have 12. We can go from this side also, can we? No, if we go from this side, then I would be swapping the most significant bits and all that. So most significant digits. I don't want to do that because that might that might come out to be a huge number, right? So what I'm gonna do instead is I'm gonna say, hey, I'm gonna go from this side, so it's 2. So then I see there's something smaller here, so I immediately swap it. So I'm gonna be 2 1. Okay, and then since the swap is 1 now, we keep on just appending those numbers to it. That's pretty much it, I think. Okay, but what happens when a number is 691? Even if this is 6921 has to be the number, and here if you have 6192, well, here immediately the swap values would be 6912, but there can be 6291, correct? Next greatest number, next smallest but greater number than 6192, considering all digits are same. Okay, so here this has to be 6291 and not 6912. This is gonna be the problem. 6291. So here six 192. So you have 2, then you have 9, then you have 1. So 1 has to swap. But the problem here is this 2 is smaller. How do I... What is it saying? Scan from the right. From the right, find the smallest digit greater than. Swap 1 2. Yeah. Tick, 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 tick. Okay, so what you're trying to do is you're trying to scan from this side, and the moment you have a drop, this is what you look at. Okay, so on the right hand side, you have to find, on the right hand side of this number, you have to find the immediate next next spot. You have to find the immediate next greater value than this. If you cannot find one, you have to return -1. Well, if this is the case, if you found one on this side, there has to be something on the right hand side, because this was greater, right? This was greater. Okay. Okay. So what is the problem statement here? Let's see. So first thing we're gonna do here is okay. Well, we don't need it to be this. Okay, we don't need it to be this. So int temp equals n, while n is greater than 0. Um, it means there is 2 numbers left. N mod 100 would give me 29. Sorry, 91. How do I get 9? Divided by 10. And here I want to use temp. In second is this. First would be 10. Okay. Int digit is -1. If second is less than first, it's not second, let's call it 100, let's call it 1. So if this is this, I'm simply gonna say digit equals 100, and I'm gonna break it out. Or what if it's a single number? If it's a single number, we don't care anymore, and we have to return. If digit is this, then -1. So let's first see if you actually nailed down. Wait. Temp equals temp divided by 10. So actually, let's look at this. Okay, so let's do some more test cases where it's not possible anymore. 2 1 1, maybe this 9 6 2 1. So for every one of these, this has to be -1. Cool. Cool. Okay. So it can be Okay, so it's a full range. So it's a full range. Ah, oh. It's the full range. You know, one of the things here is that it's gonna be off one space because it's always gonna be this huge. It's always gonna be this huge. That's all. So it has to be length 10. So let's actually do that and not do this kind of thing. So here int digits equals this thing. Look at that. Does it read what I type here? It's weird. So while this thing is this, cursor is 0. I'm sorry. If cursor is 0 or digit is less than you know what we always say, digits of this thing is this. Okay, if digits of cursor -1 if cursor is greater than 1 and is less than digits of cursor -2, I have to break here. So if cursor is equal to 10, it means we pushed everything, and yeah, so this should also technically work here. Let's see. Awesome, it didn't work. Most of it didn't work. Okay, system out print ln cursor. Okay, so we try to see here exactly what is going on. So the cursor is 2, that's fine for that. The cursor is never 10. The cursor is always the size of what you have pushed through. So maybe this is not a good option here, because again I have to kind of track where it ended and things like that, like what is the number of digits and all that, which we can do using log something, right? But I don't feel like that's a good one. So I'm going to do this here. Yeah. So I'm always checking that you have at least 2 digits. And once you have 2 digits, the first one and the second one, first and second. First and second from human readable perspective. Okay. First is 3, second is 2. Okay. So we know for a fact this is gonna work. Now what we need to do here is we need to exactly know the position where we hit that. Correct? Int position equals 0, and here once you do break out, position plus plus. So I also want to look at how this works. So class solution. Here what I'm expecting is position is -1 here. Wait, what? Wait, what? Wait, what? I'm going crazy right here. I just returned 2 here. Why is it outputting -1? What? What? Dude. How come digit is not set here? I'm very confused at this point. So how come digit here is not being set? Huh. कैसी लग रही है तबीयत? क्या कर रहे हो? क्या कर रहे हो? अच्छा, अभी भी बुखार लग रहा है क्या? हेलो. Okay. हाँ. I'm not getting why you're returning -1. Why is digit -1? Digit has to be this. Second. You know what? I know what the problem is. Because because it never went inside the loop. Cool. Now we have to return position from here. So 12. Okay, the position is 0. So I know as a matter of fact it's 0. But if I say 6192, it has to be 1. Which we need from the other way around. Yeah. Actually, that's what we're looking for. So now we can simply say position is always 1 actually. We can say position in here. We can do that. Now what we have to do is what we have to do here is look up for the next greater element after 1. Next smallest greater. So it cannot be 9, it has to be 2. It has to be 2. And you know what I'm thinking? The maximum position it can have is 10. So why not just do a for loop? For int I equals position and greater than equals 0 minus minus. So temp is back equal to end. So let's just say temp mod math pow 10. How about that? Well, can do that. So let's remove all this stuff. Just want to look at 6192. So let's remove this. Okay. 202. Wait, what? So let's always say this is minus 1. Okay? Yeah. So you take this and you divide it by 10. Then it says 900. So let's just say position was actually 0. Yeah. Like this. 90. 900. I can again go from the right. Why do I have to do that? While temp is greater than 0, temp mod 10 int remainder. This is if remainder int second position equals 0. If remainder is greater than the digit, we need to return a break and second position plus plus temp equals temp second position. Let's see. 0, correct, because that's the first one. Okay, so here if I would have said this, it would have been still 0. Now we have to take a particular number at that position and swap it. You know what? I think this is really complicated. This is really complicated. Okay, so temp is n int array 10. In cursor is 0. While temp is this, we can simply go ahead and say temp, sorry, array of cursor this thing, and then this here. Okay, so right before that I can simply say if array of cursor is less than array of cursor minus 1, we do want to break. Cursor has to be greater than 0 and this thing. Okay, my bad. Yeah, so this has to be greater than 1. That's correct, my bad. Okay, so this basically gives a thing which says boolean false and true. If flag, simply return -1. Otherwise, int swap one index would be cursor -1. That's one thing. Okay, that's one thing. Boom, 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 boom. We can do this. Well, let's just do that. Okay. Okay. So now, in here, if I say for int I equals 0, I less than cursor minus 12. If array of I is less than this, we cannot break. int swap index 1 is -1. Swap index 1 is this. If swap index 1 is equal to -1, we're going to simply return -1 here. Okay. Otherwise, we again gonna start I equals 0, I less than swap index 1. In swap index 2 is this. So if array of I is greater than array of swap index 1, swap index 2 is I, and I'm gonna break. Okay. Okay. Int temp is gonna be array of swap index 1. So array of swap index 1 is 2, array of swap index 2 is 2. So we did the swap in here. Why do you need temp? Okay, so simply reuse. You can simply reuse a binding here, right? Without much. Okay, cool. Next thing what we want to do is long number equal 0. For int I equals 0, I less than cursor I plus plus. So I'm gonna take the digit array of I into int power equals 1. So into power number plus this thing, and reassign number to this. So power is this. So this becomes kind of easy. So let's say this is long. Okay. If number is greater than integer max, return -1, else return int this thing. What about that, buddy? Look at that. Look at that. So let's see if this is the correct thing. Fuck. But I feel after the swap, we have to sort this thing. That should be it. Range from index. So I'm going to swap from 0 to swap index 2. Can I give it a comparator? Oh, only for t, not for integers. Okay. So we have to sort it in the other way. Well, we can do a little bit trickery here and say this is integer. This is gonna be very wrong, because now I can give it a collector, comparator dot reverse order. That also didn't work. Yeah, it cannot be 9-1. It has to be 4-1-4. So from 0 to swap index 2, it has to reverse in the it has to, yeah, that is not most likely it. Yeah, I just gotta be back. One quick thing. Okay, feedback. And yeah, man, today has been a giant pain in the ass where uh, yeah, honestly, I want to solve something else because Leetcode is not going great. Run the ID. Okay, no. Okay, ah. Mm-hmm. 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 Uh, yeah, honestly, I want to solve something else because design spreadsheet. Let's see. A spreadsheet is a grid with 26 columns, labeled A to Z, and a given number of rows. Each cell in the spreadsheet can hold an integer value between 0 to 10.5. Int rows initializes a spreadsheet with 26 columns, labeled A to Z, and a specified number of rows. All cells are initially set to 0. You give it a cell, and then the int value sets the value of the specified cell in the format AX, A1, B10, where the letter represents the column from A to Z, and the number represents a one indexed row. Okay. Reset cell. Okay. And get value string formula. Evaluates a formula of the form, the string, where X and Y are either cell references or non-negative integers, and returns the computed sum. Okay. Hmm. Hmm. Can be 10 plus few rows, and so that can be generally a sparse matrix. And if you generally do a sparse matrix, it kind of is a problem because like it's a sparse matrix, so you are wasting a lot of space. So usually with a sparse matrix, what you can do is you can actually represent it as a hash map. Okay, so you can actually represent it as a hash map where you can say, okay, A1 is 10, A this thing. So that kind of becomes a little bit easier to actually figure out. So the good thing is that the number of columns is only 26 and the number of rows is dynamic, so it can be anything. And here, what I'm gonna do is, so formula is in this particular format. Parsing the formula is also fine because it's equal something plus this thing. So we can always skip the first one, split it with plus, get a left and right. So if the left is starting with a character, it means it's a reference. If it's starting with a number, it means it's integer itself. So we can just parse it as an integer. Right. So that is the trick that we're gonna employ here. Okay. So let's see. Spreadsheet. spreadsheet. Okay. Private final map. I don't think that's required. If matrix dot contains this thing, well, why do I have to check? I can simply put the value there. Yeah. So reset. I'm just gonna say matrix dot remove compute if present this thing. I'm gonna return null. If I'm not wrong, if you return null, it's gonna evict the key. Exactly. See, if the new value is null, it basically removes it. Okay, so this is cool. So we have to parse the formula and private string parse string formula. So what I can do is what I can do here is a simple thing where I can say for not for formula dot split okay. I have already done boarding pass. Good night. Okay. Good night. Yeah. Okay. So I'm gonna split with an equals formula dot substring begin index is 1 dot split this thing string and simply return this. The reason why I explicitly moved this logic to a function is because now I can change the function without changing this. So it's a little bit of code principles of open closed within the function and not to the class. I mean, again, someone might come and say these principles are only for classes or object oriented, but I mean, you can implement or think about these principles whenever you do general software engineering is what I feel. All right, so here string parts is equal to parts the formula, and maybe you call it formula parse formula. Okay, so string LHS is equal to, the question here is, will it always be plus? The formula is always in the format x plus, where x and while are either valid serial references or non-negative integers and with values less than or equal to 10.5. So it won't ever be minus. So that's okay. So that's why we can simply do a split in here. So parts of this is a very rudimentary parsing, but works because, yeah. Okay. So now, what I can say here is, LHS dot starts with, so we cannot give it a regex, we have to give it a prefix. That's the problem, which I'm not so sure about. What is this, by the way? We can do region matches, I suppose. So you can give it a offset. No. LHS dot character at 0. Again, we are considering that this is this thing like a valid formula. Character dot is letter. If this is this, okay. String. So string. Int LHS is 0, RHS is 0. So here LHS will be matrix dot get this particular cell. Okay. Well, get can fail, so get or default 0. Okay. Else LHS equal to integer dot int value. Not int value, sorry. Parse it. You give it LHS string. And you can do the same thing with RHS. So here, my bad. RHS string. So this is RHS string, RHS string, return LHS plus RHS. I think that should be it if I didn't do anything stupid. We can remove this, because we actually initialize it in both the branches. So that's why it should be what it is. So let's see, hopefully I didn't do anything stupid and this works. Motherfucker, okay. Not a huge error, sorry, not a huge error. Okay, awesome. Yeah, boy. Do I have to do that? No. Why is system out println parts arrays dot toString? That is weird. Oh man, I am idiot. Has to be plus. Dangling meta character. Ah, because plus is also one used in the rejects, so it got issues, so we escape it. Okay, now it's cool. Now let's go and see if it actually passes the test or it fails entirely. Oh, thank God it passes the test. Okay, finally. Can you give me some notes? I don't know, just notes is use a hash map or sparse matrix to save space. Else is straightforward parsing. Nothing complicated. Just split. Yeah. Matrix to save space. Yeah, that's pretty much it. Cool. So we at least solved one problem in a day. Yay! And we solved the problem which Google asked. That's good. So this is at least a dopamine hit for me, at least now, because since morning I'm saying since evening, since I started stream, yeah, I was able to solve even a single, right? Sorry. Okay, what next? End queens I'm not going to solve because yeah, the basic question is in how many ways you can keep end queens in an n cross n chessboard where no one can attack each other, if I'm not wrong. There's n queens on n cross n chessboard such that no two queens attack each other, and given an integer n, return all distinct solutions to n. So one thing you have to understand is this distinct solution. So even I can say that, oh, what if I place this guy here, right? No, because if you tilt the board, it kind of becomes the same thing. So that's why like we have to also take care of that, I feel. Okay, we also have to take care of that. So a little bit. Okay. But you know what, one of the things I actually thought about, okay, so you actually have to place the guys and send it here. So I think there's also one more problem where you have to keep a count, but anyways, so one of the things that I was actually thinking about is so let's say it's a 4x4 chessboard, right? So 1 2 3 1 2 3. So one of the thing is that if I place a queen here, so I need 4 queens, right? I cannot place any queen here, all right? So I can place a queen here, I can place a queen here. Like what's the next possible solution if I would say not this? So if I was going in this direction, this is where I can place. If I was going down diagonally, this is where I can place. If I go down like this is where I can place, right? So let's place this. So if I place this guy, then again, so I cannot go this direction because I already came from there. I cannot go up. If I go this direction, there's nothing. If I go diagonally, there's nothing. If I go down, this is where I can place. Okay, this is where I can place. And if I go diagonally on this side, this is where I can place. So if you think about it, if I would have not taken this path and would have, you know, first put this, these two things would have come. So once we have placed these three, let's say, now I would go to this. So this is already done. This here I can go and see, oh, it's already placed there, so I don't have to take care of anything. Diagonally up is not there, diagonally this thing is not there, diagonally down is not there, this thing is not there. So it kind of something that I cannot place. I cannot place the fourth. Wait, this is the 4 queens, right? Isn't this 4 queens, buddy? Yeah. So why is this not one of the solutions? Then again, you can also place here. So if you place here, then this is one of the solutions. So it's like this. If you place here, then this is one of the positions. This is one of the positions. It's one of the positions. I'm not sure why I have to do here, 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 here. Why can't I do here, here, here? What is the issue? Distinct solution. Yeah, that's the thing. Like, I have to figure out when the board is distinct. So, like, if you do this way, if you rotate it, kinds of become the pink one, right? So that is why I think it's just one distinct solution. And then you can place one here, and then one here, not here, here. Right, so if you place one of them here, so I feel it's kind of like a DFS thing where you place one of them, then you explore all of the cells and see if there is anything nearby, and you don't place it. So if I go here, can I place? No. Let me go here. Can I place this? Yes. Can I go here? Can I place this? So I go down another single path. So if I do place one here, one here, one here, then for this, these two would be the possible solutions. Right. So yeah, I don't want to solve this. I feel this problem is I don't know. I just feel, and then n is always a 9. So technically speaking, it's always gonna be O of 1 solution for time, because you have, oh no, it's not always 9. So my bad. Sorry. So it's gonna actually depend on 9. So technically speaking, it's gonna go to like in powers. So if you go down the recursion tree, it's gonna be huge. Right. So for this, you have multiple options. For this, you have multiple options. For this, you technically have m into n minus 1. Right. So then let's say you choose this one. So you have m into n minus 2. So similarly, like this, you have m into n minus m. Right. So if you multiply that, that's a huge number down the tree. So that is why you need to do some sort of optimization to figure out what exactly you want to do. Okay. But yeah, I'm not going to do that. I hate that problem. So what should we do? This seems like an interesting problem which I never solved. Plus it's an easy one. Maybe I can nail it. Merge two binary trees. You're given two binary trees, root 1 and root 2. Imagine that when you put one of them to cover the other, some nodes of the two trees are overlapping, and while the others are not. You need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then sum the node values up as the new value of the merged node. Otherwise, the not null node will be used as the node of the new tree. Return the merged tree. The merging process must start from root of both trees. Okay, this seems like a fairly simple problem, honestly. So here, it is 1, 2, 3, 5. 1, 2, 3, 5, and then there is 2, 1, 3, 4, 7. 2, 1, 3, 4, 7. Okay. I want to add a little bit here. Let's say 9. Okay. So the very first thing we do is, if both are null, we return null. If one of them is null, we return a new node with the value of the non-null one. Okay. Mm-hmm. So let's take this tree and we'll return back. So technically speaking, we have to return back a new tree, no matter what. Hmm. So merge to binary tree. Hmm. So here itself, what we're gonna do, if root1 is equal to null and root2 is equal to null, we're gonna return null. If this is the case, so let's do this. Tree node, new node equals new tree node of 0. If root1 equal to null, not equal to null, so let's say this is this. If root1 is equal null, I'm going to simply say new node dot value equals this. Hmm. New node dot left equals, so this here would be null, and root2 dot left, and right would be right. Else if this is this, this is this, so root1 dot left, well, this has to be null. Root1 dot right, and this has to be null. Else root1 dot, okay. So here, you know what, I have a better idea. I feel int value equals 0, tree node left, root1 left equals null, root2 left, root1, yeah, cool. Yeah, so This is this. And then root 1 left is this. Root 1 right is this. If this is this, okay, cannot just do a selective search. Shit. So 2. Not else if. So root 2 left is this. Root 2 right is this. New node dot value is this. New node dot this is this. Right is gonna be root 1 right. Root 2 right. And you return that. That kind of merges the code a little bit. Cool. Can you give me the notes? Revision notes for this. Recursively iterate over the child node, over the nodes, and merge value if not null. If not null, consider children of that node for merge of the nodes. Recursively. Yes. Yeah. What? That is fine. Give me revision notes for later, for future me, not essay. Don't yap. I should. Yeah, that's fine. Maybe here. Cool. What next? Second highest salary. Is that a SQL question? I don't want to do a SQL question for sure. Yeah. This you can do it via rank and things like that. Not gonna do it. Ugly number. That seems also an easy problem. So an instant gratification and instant, you know. Well, what the fuck? I couldn't. Okay, an ugly number is a positive number which does not have a prime factor other than 2, 3, and 5. Given an integer n, return true if it's an ugly number. Number of visible people in a queue. Let's look at this. Oh, I already attempted it. Yeah, I think I was doing it today. Yeah, so I think I did it in a n square solution where it became a TLE. Yeah, so this here is the TLE. Yeah. That were a very this case. But what we do, length minus 1, current max is 0. So if the height is greater than or equal to the current max becomes that and counts plus plus. If the height is if the current height is greater than or equal to whatever height we are looking for, we break. Why do we break? So what exactly did we do? I forgot. What exactly was the problem? There are n people standing in a queue, and they are numbered 0 to n minus 1 in left to right order. You're given an array of heights of distinct integers. Distinct integers is more important, I think, where heights represent the height of a person. A person can see another person to the right in the queue if everybody in between is shorter than both of them. More formally, the ith person can see the jth person if I is less than, so left of j, and the minimum height of this thing between this is greater than the maximum height between. Okay, so can I see this person? Yes, I can always see the next person, I believe. Why can this? Okay, so I always have to look to the right, so I can always see this person. And between these two people, this is the only one that you have, so you can do that. And then this is this. Okay. So between you and me, everybody is shorter. So I can see that person. So for this guy, I can see this person, I can see this person, I can see this person, no, I can see this person, yes. And because everybody's shorter here, I can see this person, yes, okay. So this is more of an n-square solution. And I feel the thing that you actually have to do to reduce the cost of it is basically what you have to do here is you have to do a monotonic scan. So first comes 10, your stack is empty, so you put in 10, 0, 0, 1, 2, 3, 4, 5. Maybe I can reverse the question. I can ask the question, can I see this guy to the left? If I ask the question that can I see this guy to the left, I think the answer is I can only see till that point where someone is greater than me. That's all. No, that's not correct, because if there's a 17 here, between 17 and 19, the minimum of 17 and 19 has to be greater than whatever. Okay. So yes, right. So I can only see till 11. Even if this guy was ridiculously tall, I cannot see. That's the point. So yeah, this intuition works fine. So I just reversed the question and I said, look from this side, can I see that guy? So I can only see that guy till the point I have someone next greater of me. So who's the next greater of 11? 1, 2, 3, 4, 5, 6. Who's the next greater of 11? Who's the next greater of 9? 11. So for 11 there is no one, so I'm just gonna say z minus 1 for now. I'm just gonna say that. For 5 the next greater is 2. For 8 the next greater is 0. For 8 the next greater is 0. For 6 the next greater is yeah, okay, that's correct. Sorry, for this guy the next greater on the other side, next greater in the sense previous greater, sorry, is basically minus 1 again. Okay, let's just say this is what the situation is right now. So how many guys can I see if I ask a question here? If I ask the question here, well, technically speaking, I had to answer who's the furthest. No, I cannot still answer because there can be a smaller guy in between. It's kind of wrong, you know, because if there was 11 and there is 17 and there was 15 and 13, I cannot see 13. I cannot also see 17. Okay, it's very confusing. Like always in my mind, I'm like, okay, he's Lamba. Why can't I see him? My bad. Okay, so how can I take this information and help? So I don't think so I care about this. I can start from here. So this is 0. So 1. This is 0 plus 1. This is 2. 0, 1, 2. So this is 1. This here is minus 1. So like this. And then here it's 4. 0, 1, 2, 3, 4. 1. So it would be 3, 0, 1, 0, 1, 0. That is wrong. हाँ बोलो. हाँ खाना खाते हैं 5 मिनट में. Okay. So so what if we use this information? 2, 3, 4, 5, 6. We said this is minus 1, so we don't consider anything for here. We said this is 0 and 0, so this is 2. So after that, this is 0, so this is done, this is done, this is 2. 0, 1, 2. Then this is minus 1, we don't do anything. This is 4, 0, 1, 2, 3, 4. we just say 1. Then we say 3, 1, 2, 1, 2. Is that what the answer is? 3, 1, 2, 1, 1, 0. 1, 2, 3, 4, 5. And the 0 of course when I end. Yeah, that's not correct. That's not quite correct. So, the fuck is happening here? Bye. Mm-hmm. Hmm. We can always go on the other way and say ki, like I mentioned, like who's the previous greatest element, the index of the previous greatest element, right? This is gonna be -1. This is gonna be 4. This is gonna be -1. This is gonna be 2. This is gonna be So what if I just do a monotonic increasing thing? So I say 10. Then you have 6. So if you have 6, um, so you have 10, 6, and you can scan from right hand side. You can see 9 is gonna pair with 11. 11 is not gonna pair with anything. So this is gonna pair with 2. 8 is gonna pair with 0. 6 is gonna pair with 0. 10 is not gonna pair with anything. So we don't care on this side, right? We only care about here. So what is the 10-5, which is like n log n solution that we're looking for, right? Time complexity with constants. If I look at that, 10 to the power 6 is n log n, yeah. Okay. Mm-hmm. So you have 10, then you can say, okay, for 6, in between, what is it? From 8, you can say in between. In between what it is. Then 5 is smaller. So since 5 is smaller than 8, we have to somehow, like, we cannot see any one of those 10, 6, 8. We cannot see any one of those, right? So we have to somehow figure out a way where we simply skip those. And what is the way here? It seems like a monotonic array. I just have to figure out what exactly, like from which side I have to create the monotonic array. That's all. monotonic stack, sorry. Same thing, I guess. Anyways. Hmm. So I push 10 first, then 6 comes in. And as a matter of fact, I can say that the index position between 10 and 6 is 0. I mean 1 technically. So technically, yeah, it's 1. So if it's 1, I can obviously see that guy. I can see whoever is next to me, whether tall, short, doesn't really matter. I can see that guy. The question is, can I see the next guy? The next guy is 8, which is not younger. What is that called? Taller than 6. So I can remove 6 here, and I can say 8. So 8 comes in. So whenever something bigger comes in, I remove the smaller one. How will that help? Because when 5 comes in, I am not bothering about these things and I remove all of those. No. We'll listen to the song again. Okay, I'm gonna increase the volume a little bit. So you have 10, 6, 8, 5, 11, 9. So you had 10 first, it came in. So 6 is smaller than 10. Maybe I evict it. 8 is smaller than 10. So I evict that. 5, but I lose the information that what is in between, right? I lose that kind of information, and I need that to actually say that, okay, what's happening and what is not. So one of the things I'm thinking to do here is uh, let's look at hints, man. Okay. How to solve this problem in quadratic? Okay, we already actually solved the problem in quadratic complexity. For every subarray starting at index I, keep finding new maximum values until a value larger than a array of I is found. Correct. So this is what we did for a quadratic equation. Since the limits are high, you need a linear solution. Yes. Use a stack to keep the values of the arrays sorted as you iterate from the end to the start. Okay, so yes, exactly. We're coming on the other direction. So keep popping from the stack in sorted order until a value larger than array of I is found. These are the ones that person I can see. Yes, we need a monotonic stack, that's all. So we push in 9. Then what we want to do is 11. Keep popping from the stacked elements in sorted order until a value larger than array of I is found. चलो खाते हैं. मैं बना रहा हूँ, रुको. मैं बना रहा हूँ, रुक जाओ. रुको, मैं बना के देता हूँ. Okay. 10, 6, 8, 5, 9. So here I get 9 and I say 11. For 11, I want to keep it sorted. I want to keep it sorted, so I push that in. Then a smaller value is 5. So 5, I don't want to. Then comes 8. I don't want to. Hmm. Hmm. Next dollar makes sense. How is this go off in? If I submit this, it's gonna work. What I do want to do here is just give me a second. क्या हुआ? Okay, I need to stop the stream immediately for some reasons. Yeah, so thank you so much for which tuned in. Thank you so much. I don't know how good of a session today was, but yeah, some days it happens that you cannot solve all the problems. It happens to everybody. Um, yeah, I'm not gonna stream anymore tonight. So see you guys soon tomorrow. Thank you.